At this time, it's my great pleasure to introduce to you Dr. Elliott Kellner. I'm particularly interested and excited to introduce him because I am the interim dean, and so far I've made one faculty hire, and it's Dr. Elliott Kellner, so let's see how he does, no pressure.
All right, thank you very much. Good afternoon. My name is Elliott Kellner. I was asked to come and speak here today, introduce myself, introduce this new position that was founded, which is the Chesapeake Science Advisor position, and explain a little bit more about what the mission of that project is and what it is that I'm going to be doing. And then to keep it from seeming like a strange aside to this whole program, I'm going to tie it back to the work that we're going to be doing at Raymond Memorial Farm. So just to start, I want to introduce myself. Again, my name is Elliott Kellner. I am a physical hydrologist. So I'm the second hydrologist that you get to listen to today. So man, you're coming up spades for you guys. And I received my PhD from the University of Missouri in 2015. And I'm proud to say that I cut my teeth as a researcher working as part of that Hinkson Experimental Watershed Project that Dr. Hubbard presented to you. As a physical hydrologist, my work focuses on environmental water and all of its various components. So everything from water vapor in the atmosphere to the groundwater beneath your feet and everything in between. How the water moves between those various components, streams, rivers, precipitation, the ocean, everything. And then also the way that that water changes and the way that water quality changes between those various components. And then my research specifically to date has focused on comparing how human impacts on the landscape, the way that we're using our land and water resources are impacting our water quality as compared to climate variability, because there's natural variability in water quality regimes and water quantity regimes, and sometimes it can be difficult to tease out those specific contributions of a single practice on the landscape without covering a lot of research context. So I moved here to West Virginia in January of 2016. I've been working as a part of the Institute of Water Security and Science at West Virginia University, and was recently tasked with stepping in for the Chesapeake Bay Science Advisor position. I'm going to talk a little bit more about what that is and what my mission is here in a moment. But just to make sure that we're all on the same page, I am sure that everyone here has heard of the Chesapeake Bay, heard of the Chesapeake Bay watershed. But there are a few interesting statistics that I always find curious. First of all, it's 64,000 square miles, which is large, but it has over 18 million people living in it right now. It's a high population density as compared to watersheds out west, where you might have large farms spaced out over the course of miles. You might have one person every few square miles. That is not the case in the Chesapeake Bay watershed. And the other interesting stat to remember about the bay is that the land-to-water ratio is 14 to 1. Now that might not mean anything, but that's the highest land-to-water ratio of any coastal water body on planet Earth. And what that means is that the sum total of human activities on the landscape are being concentrated, like sticking a magnifying glass up to the sun. We are concentrating our impacts on water quality to the bay, and that's one of the reasons, one of the many reasons, that we're seeing such extreme water quality impacts of human behavior on the landscape. So just a brief history on the Bay Watershed program. People have been observing water quality degradation in the bay for decades, over a century. So decrease in water clarity, sedimentation of waterways, loss of submerged underwater vegetation, degraded fisheries, degraded oyster beds. All of these observations have been going on for decades. Since the 1980s, there has been an organized effort to restore the bay, with different states coming in and sitting down, trying to cooperate and coordinate their bay efforts, their bay restoration efforts. But unfortunately, insufficient progress led to legal consequences as the result of some lawsuits filed against Bay watershed states in the 1990s. And as a result of those consent decrees, the U.S. Environmental Protection Agency had to step in as part of their mandate under the Clean Water Act to act as the new regulatory arm over what's happening in the Bay watershed. And again, a lot has happened since the 1990s, but the U.S. EPA sat down with the different states and different jurisdictions and worked on creating this massive document called a TMDL. It's total maximum daily load. And the easiest, the best definition that I have heard or seen of what a TMDL really is it's a pollution diet. So you stipulate what you want to use a given water body for. It might be recreation, it might be support of aquatic wildlife, it might be drinking water. But whatever your designated use is, then you figure out what the threshold is for a certain pollutant before it can be, the water body can no longer support that use, and that threshold becomes the new diet. And so in 2010, the US EPA published, they set the TMDL for the Chesapeake Bay, and that translated to a 25% reduction in nitrogen, 24% reduction in phosphorus, and 20% reduction in suspended sediment loading to the bay. So those were the three pollutants that the EPA defined as being most likely responsible for the various types of water quality degradation they were observing in the bay. So what does that mean for us in this room right now? Well, unfortunately, agricultural land uses have been identified as a primary source of all three of those pollutants to the Chesapeake Bay. And you can see from these graphs up here, these graphs are the result of model simulations by the Bay watershed model. That model estimates that about 60% of suspended sediment being delivered to the bays comes from agricultural practices within the watershed. About 45% of phosphorus being loaded to the bays from ag, and then about 36% of nitrogen is being sourced from agricultural land use practices. So agriculture has been identified as a gross polluter as part of this program. And there have been, as I'm sure you're aware, various and sundry efforts targeting agricultural producers trying to reduce these types of pollutants being loaded to the bay. And into that gap, so there are various state and federal agencies, local municipalities that are all a part of this gigantic Chesapeake Bay program, this program to improve the water quality in the bay. But one of those agencies is USDA NRCS, the Natural Resources Conservation Service. And I am sure that I'm preaching to the choir here because you guys probably know all about NRCS and what they do. But NRCS has stepped into this gap, and as opposed to draconian regulation and arm twisting, the NRCS fulfills their mission through incentive-based voluntary conservation programs. So the NRCS works with local landowners, local agricultural producers to implement conservation agricultural practices on their land using incentive-based programs so that it's a win-win scenario. And through those programs, they not only improve agricultural management at the field level, at the farm level, they're also improving bay water quality. And it's an important thing that I want to make sure that I state over and over again. Like one of the take-homes is that it's not just about bay water quality. Because I know that when you're sitting in West Virginia and you have a talking head, beating a drum about Chesapeake Bay water quality, it can start to seem like a pointed finger, but ultimately, what's good for the Bay is good for West Virginia. And what's good for Bay water quality is good for individual farms, and it's good for our watersheds and our streams and our rivers and our agricultural producers. And this improved agricultural management is one of the very few examples that I think you will find in the environmental policy world of a win-win scenario, where what is good for an agricultural producer and what is good for a local watershed is also good for the end user, which is the Chesapeake Bay. So the new science advisor position, this is a cooperative project between W.P. Davis College of Agriculture, USDA NRCS, who is providing all of the funding very graciously, and also us in the Institute of Water Security and Science. And the mission it's pretty straightforward. It's, first of all, hoping to increase the technical capacity for the various USDA and NRCS Bay-related programs and activities. So I am bringing the perspective of a physical hydrologist to what is happening with these NRCS programs, these conservation management practices, and then additionally hoping to provide a point of coordination and leadership for the various ongoing efforts. And I say coordination because there are so many different agencies, both at the state, federal, and municipal level. There are so many different committees and nonprofits and foundations that are all participating in this gigantic Bay program. I was actually telling Isaac earlier that calling it overlap is an understatement. It starts to look like pages in a book. There are so many different agencies working towards the same goal that at some point the right hand forgets what the left hand is doing, and we need improved coordination to make sure that we're pulling the rope in the same direction when it comes to improved agricultural management and improved bay water quality. So hopefully providing some coordination and leadership for those activities and programs. It's a simple mission. The responsibilities, so we're talking like specific tasks, what are you actually going to be doing as opposed to some sort of lofty claim of providing leadership for whatever that's worth. These are the things that we're actually hoping to do within the course of the next few years in this program. Supporting and promoting adaptive management of voluntary agricultural conservation programs. Again, I just want to stress, voluntary agricultural conservation programs, right? Adaptive management, everything about that NRCS mission, it is collaborative. It is about improving working lands with the people who are working them, right? As opposed to that kind of proverbial arm-twisting approach. Coordinating implementation of outcome-based scientific research. I'm going to come back to that in a moment. To quantify the impacts of these various conservation practices and hopefully to guide future program delivery in the Chesapeake Bay. Providing technical assistance, which I mentioned, and then again collaborating between all of the various federal and state agencies that are working together and maybe are not always working together, quite frankly. So what is it? So why am I telling you about this, right? Why in the midst of talking about Raymond Memorial Farm is this guy telling me what he does for a living? And the answer is because Raymond Memorial Farm is located in the Chesapeake Bay watershed. That's thing number one. Thing number two is it comprises a unique opportunity to actually conduct this outcome-based scientific research to quantify the impacts of conservation. As opposed to doing it at some site, some remote site in a different place where if the results don't pan out, the scientists can say, well, you know, every spot's different, you know, it all depends, guys. We're actually going to do this research within the Chesapeake Bay watershed, within one of the physiographic regions that is a part of the watershed, to make sure that the results that we generate are directly applicable to improving bay water quality and also to improving the water quality in our own streams, our own groundwater quality here in West Virginia. Now, examples of again, you know, specifically, what do you mean specifically? Examples of what I'm talking about, you know, we talk about best management practices. That's probably a term that you hear a lot. Well, how do these best management practices actually affect water quality at the field scale? How do they affect the bottom line for an agricultural producer? And the answer is, we know for some of them, but we don't for others. And so why don't we put some of these best management practices in place in a working farm and test them and see what comes out the other side. Let's measure the results and let's come up with some hard data about what exactly, how these practices are benefiting our watersheds and benefiting our producers. Also, you know, you can't talk to a scientist these days without him mentioning something about climate change. So we do want to also be monitoring the impacts of climate variability, because there are times when the primary driver of a water quality regime might not be land use impacts. It might be the difference between dry years and wet years. And we need to know that so that when we're making recommendations about regulations and new policies that are being passed, those are being informed with the best science possible about our changing planet, to make sure, again, that working lands and agricultural producers are being served as well as they can by our research and our program. And then finally, filling in some of the research gaps, things that we actually don't know a lot about in the scientific community right now, like field to sub-watershed scale nutrient transport and transformation processes. And that's a mouthful But basically what it boils down to is that the form of nitrogen that you apply to your field is not the same form that we find downstream in a watershed or underground in the groundwater, and we need to know more about how that nitrogen, how phosphorus is changing as it moves along this path, how it moves along that path. Again, to be sure that when we are informing regulatory efforts, that when we're informing new policy, we're doing that with the best, most accurate science possible, so that agricultural producers are being served by the scientific community, right? Science as service, it's the whole land grant mission. It's one of the reasons that I'm excited to work at WVU, which is a land grant institution, is because it is community service through science. And that's what we're hoping to do at Raymond Memorial Farm, and that's what we're hoping to do with this new Chesapeake-based science advisor position. So with all that, I will say my thanks, obviously, just to make sure that you know that this program, it is the result of a unique collaborative effort between WVU Davis College and the Institute of Water Security and Science and USDA NRCS, in addition to several other funding agencies and partners. So with all that, I will say thank you. Again, my name is Elliott Kellner. If you have any questions for me, you can catch me afterwards. Know that you will probably be seeing my face increasingly popping up at functions like this as I try to move through the community and meet as many people as I can. And feel free to bid my ear if you have any questions. Thank you very much and have a good day.
So, Elliott, sounds like you'll be doing a lot of traveling. Okay, so I don't see you for a while. I should be okay. All right.